Hello and welcome, ladies and gentlemen. We are back for another YouTube video. I've been slacking a little bit. I apologize. My plan is to get a bunch done tonight. We'll see what I can do. Anyway, we are in Module 1, Topic 1, Module 1, Topic 2, and then this is Packet 1 of Topic 2, or also known as Lesson 1, okay? We're going to do the talk today, draw what you know. So a lot of these require, so basically, here, I'll read the question first. So we have this big long paragraph talking about theorems and postulates. Theorems are things that we are going to end up proving, can be proven true using definitions, postulates, or other theorems, and then a postulate is a mathematical statement that is not proven, but is considered true, okay? Those are both vocab words that I covered in the vocab section that is in this playlist, okay? So if you don't know those, you can go back, check that. You can see it here. You can read it in your packet. You can look it up on Google, whatever you prefer to do there, okay? So we have this. It says, the table shows the conjectures that were made in this lesson. You will prove these as theorems in upcoming lessons. So far, all of these, all similars are circle, vertical angles are congruent, stuff like that. All of these statements are conjectures. They are assumptions that we are making, but we haven't proven them, or we haven't proven them yet. So we will do that eventually. We will be doing some proofs at some point in this class, but that day is not today. So number one here, we say, based on your explorations in this lesson, draw an example of each conjecture. So to save myself some time, I've already constructed all of these, and then I'm just going to talk through them. All of these constructions I did with a compass, okay, to construct all the circles, and then a straight edge, and then I did use my ruler here to measure the length of these, okay? So far, we have a conjecture that says all circles are similar. So we can assume that all circles are similar in structure, and in fact they are. They are all centered around one point, and they are equidistant from that point all the way around the circle. Okay. The reason that they are different and they aren't all congruent has to do with the length of their radius, also their diameter. Okay. So a diameter of a circle is twice as much as a radius. So the diameters of these would also be different. I just chose to measure the radiuses here, or the radii as we now know them, okay? So I measured this. This was about 6/10 of an inch. Sorry for the shaky cam. This was about 6/10 of an inch, and then this one was 8/10 of an inch. So we can see that these circles are not the same, but they are indeed similar, okay? So on to B. Vertical angles are congruent. If you'll remember, vertical angles are angles that are opposite each other, and so the examples that we had in this packet, we had circles, and then we had two diameters that crossed each other in the center of the circle. That'd be the center of the circle right there. And then the opposite angles that were created from these intersecting lines had equal angle measure. And so you can see I have the little tick marks here. I have one in each of these to symbolize that these have the same angle measure, and then I have two in each of these to symbolize that those have the same angle measure. So another way that I could do that, going back to your algebra days, because I don't know the exact measures, if this was angle X, this would be angle X as well. And then using a different variable now, if that was angle Y, this would also be angle Y. Those are congruent. So like I said, one way that you can remember that they're vertical is that if I went from this angle straight up through the center, I would end up in the other angle that it's congruent to. Same with this one here. If I was in this angle and I went straight across through the center into this angle, those would be the ones that are congruent. So that line that we're drawing through the center to get from one angle to another isn't necessarily vertical. But if you had asked me, that I believe is how we got that name. So on to the next one. That was A and B. Now we're on to C. Okay, some of these are kind of self-explanatory, but they just need a little drawing here. So we have, when the measures of two angles X and Y are added, the sum is the measure of another angle Z. So all this is saying is that if I have two angle measures, so these on the inside of this big circle here, I have angle X and angle Y. If I add those two angles together, I will get the sum of those two angles will be a different angle, which would be Z. So I have my angle X represented here by this little angle mark here, and then Y represented by this one, and then Z, the big one, the total angle, both of them added together is this big arc here. And so I don't think that that's technically the most mathematically sound to have this big angle measure like this, but for our purposes that will work. Okay, so all this is saying is that if you take one angle measure and add it to another angle measure, that you will have a third separate angle measure, right? Like if this was 1 degree and this was 2 degrees, then we'd have 3 degrees. If this was 1 and 1, this would be 2. There's no way that you can add two numbers together to get the same number, unless that, of course, is 0. But okay, well, we aren't talking about that. We aren't measuring angles that have 0 degrees in measurement. That is just no fun. That is a line. Okay, so when you have two excuse me, wow, if you have two angles that you measure and you add them together, you get a third one. Same thing here. Okay, we're talking about arc lengths now. So if I have arc length x, so say from here to here, this is x, and then I have y from here to there, and I add those two things together, I would get a third arc length z, which is why I have this on the inside. That would be the total distance there. So same thing, if you understand this angle one, this arc one is the same, only instead of talking about angles, we are talking about arcs. Okay. Now, when two parallel lines are crossed by a transversal, so the transversal is the line that goes through our two parallel lines. This is the transversal. Alternate interior angles are congruent. Okay, so remember when we talked about some of our definitions, mathematicians weren't very creative, so alternate interior angles. So I know I'm talking about angles. I know that they're on the inside of my two parallel lines because they're interior, just like the interior of your car is the inside. And then alternate means like alternating. So if I was on this side of the line, now I'm going to be on the other side of the line, right? If I'm on, so say if I move this so that this line is straight up and down, if I'm on the left side of this line, now I'm going to be on the right side of this line, the transversal, and then those two will be congruent. And then same thing if I start on the right side, on the inside, and then I go over to the left, those two would be congruent as well. Okay, so that was E. Now we're on to F here. When two parallel lines are crossed by a transversal, again, a transversal is this diagonal line that goes through the two parallels, corresponding angles are congruent. So what I did here, this is a pretty classic representation of corresponding angles. So corresponding angles, so I just labeled all these angles with different numbers, 1 through 8. Okay, so what I have down here, these little notes, 1 corresponds with 5, 2 corresponds with 6, 3 corresponds with 7, and 4 corresponds with 8. Okay, so the definition of corresponding angles is that if you have like, well, I guess, so the one that you will most likely see is like this with the parallel lines. You can't have corresponding angles that don't go through, like with a transversal that doesn't go through parallel lines, but that we don't see very common, so you don't have to worry about that. So basically what I'm saying is know this, okay, know these corresponding angles. So the way I like to think of it, again, if I were to square this up, if I make this transversal straight up and down here, okay, the way that I like to think of it is like, here's my top left angle. Okay, so my top left angle with these two lines is going to match up my top left angle with these two lines. Here's my top right angle. My top right angle is going to measure up with my top right. Those are going to be congruent. My bottom left, bottom left, bottom right, bottom right. And then with that, okay, corresponding angles are congruent. Okay, you can just have, I mean, I didn't write this down, but you can just put angle 1 is equal to angle 5 is another way that you can write it. Okay, so all of these corresponding angles, because these two lines are parallel, will also be equal. So if you want to go angle 1 is equal to angle 5, 3 is equal to 7, 2 to 6, 4 to 8. If you want to do that, you are more than welcome to. Okay, so now we're going to look down here. When an inscribed angle, oops, going too far. When an inscribed angle intercepts the same arc as a central angle, the inscribed angle has half the measure of the central angle. Okay, so here I constructed a central angle. Its vertex in the center and its sides are radii. And then I have an inscribed angle whose vertex is on the circle and whose sides are chords. Okay, and then I didn't measure this angle with a protractor, just to kind of get the point across that whatever this angle measure is, the central angle, the inscribed angle that intercepts the same arc, remember intercepting the same arc, here's the arc, they both intercept, right? If I were to carry out both these lines, okay, they would intercept the same arc, right? So they intercept the same arc, central angle, inscribed angle. If the central angle measure is x, whatever x is, the inscribed angle measure is going to be 1/2 that. And so I got kind of squished here, and it looks like I have 1 over 2x. If you'd rather rewrite it like this, 1/2 x, you can write it like that as well. Okay, so that way it's a little less confusing. I did kind of run out of room here. So if this angle measure is x, then the angle measure of this inscribed angle is 1/2 of x. Okay, so now we have this pretty picture. Two inscribed angles that intercept the same arc have the same measure. I went ahead and did 4 inscribed angles, but any 2 inscribed angles that intercept the same arc, again, if I were to extend all these lines, which I won't on this one, but if I were to extend all these lines, they would intercept this small arc right here. So all of these angle measures, all of these inscribed angles, have the same angle measure, which again I've just labeled with x's because I didn't measure them, so I don't know what they are, but I know that they're all the same. They're all equal to x. And then another way that we can know that they are all the same angle measure is by looking at these little tick marks, these little angle marks, right? They all have 1, so they're all the same. Over here, back up here, I had 1 and then 2, which means that they're different, okay? And then I did that one earlier as well. So now on to I. When an inscribed angle intercepts a semicircle arc, the inscribed angle measure is 90 degrees. Okay, so when an inscribed angle, vertex on the circle, its two sides are chords, when an inscribed angle intercepts a semicircle arc. So here you can see I made my circle, I cut it in half. This is a semicircle arc measuring 180 degrees, right? Semicircle, 180 degrees, half of a circle. That all makes sense. Okay, the inscribed angle measure is 90 degrees. So because we're making this assumption, I just went ahead and marked all of these angles with the little 90-degree angle box that we know and love, okay? So that is our assumption. This is how you can show that. So now the next one, the angle formed by a tangent line and a radius of a circle is 90 degrees. So I drew a tangent line, I drew a radius to the same point as the tangent line touches, because if you remember, tangent lines only touch the circle in one point, at one point. So if this is the one point that the tangent line touches, I drew a radius to that point, and then the angle that is created from those 2 points intersecting is indeed a 90-degree angle. So far, those are all assumptions, those are conjectures that we have. We haven't proven anything as a fact yet, but we have a pretty good suspicion, our intuition, right? Our brain tells us just by looking at these things that we have a pretty good idea that these are all true. So we will prove them later to be facts, but for now, we are just leaving them as is. They are conjectures. I hope you all have a wonderful day. I will be coming at you with some Packet 2 videos sooner rather than later. Hope you all have a wonderful night, and I will see you in class. Adios.